In this video, I'm going to show solutions for 5 challenges that you can find on the HackerRank website. Those are the most simple challenges actually that you can imagine. You can see the difficulty easy, and those actually are the first challenges I saw when I joined HackerRank. So the first challenge is called simple array sum. You are given a simple array of small uh, integers. You can see the constraints number of elements is relatively small. The elements themselves are small too, so that means that int 32 is enough, and you just basically need to find the sum of the elements of that array. So how HackerRank works: you're given a code and you just need to complete one function. So this function was empty, and I added this line of code. So .NET and C# has a built-in function to get the sum of an array. So why not to use this function to get the result? So if you are asked to reinvent the wheel and expand this function, well, you just iterate through the array and just increment the result within each iteration. So you can also see how .NET implements this sum function. You can just pick the definition, open Visual Studio, and pick the definition, go to definition, just see how it works. It basically works the same way. It iterates through the elements and add the element to the result. So the only difference is that it also checks for arithmetic overflow, which we usually don't do because well, in this task we see that numbers are small and arithmetic overflow is not possible. So we run the code and the results are great. All tests passed. So the next challenge is called compare the triplets. So you can pause the video and read the description if you want. But basically you are given two arrays with 3 elements each. So that is hard coded. Only 3 elements, no more, no less. And you need to compare element by element. So 0 element with 0 element, first element with first element, and second element with second element. And it's like each array gets a point if its element is bigger than in the other array. So if this element is bigger than this element, so B array gets a point. So Bob gets a point. Here elements are the same. No one gets a point. And here element in the A array is bigger than element in the B array. So A array Alice gets a point. So you calculate number of points each array gets, and you need to return an array of 2 elements. So first element is number of points Alice got, and the second element is number of points Bob got. So that's the function that I completed. So I declared Alice points, Bob points, just as we know that there are only 3 elements. So I just go through those elements. If element is in A is bigger than element in B, I increment Alice points. If element in B is bigger than element is in A, I increment Bob points, and then I return a list of 2 elements, Alice points, Bob points. That's it. Very simple challenge, and all the test cases passed. The next challenge is called a very big sum. It's very similar to the first challenge. The difference is that even though number of elements here is smaller, you can see that it could be up to 1000, and here it's only up to 10. The elements itself can be big. So here elements could be up to 1000 and here they are up to 10 billion. What that means? As we know, int 32 is limited to around 2 billion. So that means that int 32 is not enough to get the correct result. And we need something big. And something bigger is int 64, which is called lon in C#. And that's basically the only difference that we need to keep in mind. But the line of code is actually the same that we wrote here. Because .NET is so great, it has built-in function that can get the sum even if it's sum of lon elements. And we need to return lon. If you if you expand this function and write your own function, well, you do the same you would do in the first challenge, with the exception you declare result as lon. That's it. You run tests and they pass. The fourth challenge is called diagonal difference. So again, you can pause the video and read the description if you want. So basically you are given a square matrix. So what does it mean, a square matrix? That the number of rows and the number of columns is the same. So what we need to do is to get this, to calculate the sum of the first diagonal, let's say 1 plus 5 plus 9, then get the sum of the second diagonal, 9, 5, 3, and then find the absolute difference. So like this, 15 minus 17 equals to 2. So we see that elements in the array are small numbers. I don't see the number of the elements of the array, how many elements in the array, but I guess it's not important. So how do I solve this? So I declare min index and max index. So because I need max index here. As the matrix is square, so it's enough, so it's safe to use one for loop and just calculate some of the diagonals like this. So this is the sum of the first diagonal and this is the sum of the second diagonal. And you can think how it should be calculated. So I wrote this those expressions to calculate the sum of the diagonals. It's very simple. And then having those sums, I just get what is required, which is absolute difference of those sums. I run the code and all the tests passed. And the last challenge is called plus minus. So here we are given an array of integers, and what we need to do is to find number of positive elements, number of negative elements, and number of zero elements, and then display the ratio of those elements. What does it mean? So there are two positive elements and we need to divide 2 by 5, and which 5 is total number of elements, and return and display this in the console. Same for the negative elements and for zero elements. So we need those ratios. So again, small numbers, small elements. So here's the function. So input is an array. So we declare number of positive elements, negative elements, and zero elements. And just iterate through the array. And if element is positive, we increment positive. If negative, we increment negative. If zero, we increment zero. So then we need to find this ratio. There is a trick here, small trick. So as those numbers are integers, and if you divide integer by integer, you receive integer. So you won't have a correct result. And we need a double here, which is array size. So I declared array size as double and put a array count there. So also a bit trick to display exactly 6 digits after the point. It's it is a requirement of this task, even though I tested and it works without this condition. But just for the sake of uh, clarity, let's add it here. And that's basically it. You run the tests and they work. Thanks for watching.